Well, it's in this light that we welcome our first guest to today's show for this month's CMSC Corner. Michael Raphael is President and CEO of Dirk Dimensions, a company providing unique solutions to complex modeling and manufacturing problems, specializing in the on-site application of digitizers, laser scanners, and much more. He's also spent several years on the executive committee of the Coordinate Metrology Society. So, Michael, welcome to the show.
Thank you, Mike. Thank you, Dirk.
Yeah, thanks for being here with us today. Well, metrology industry, it's really interesting in terms of its history and its ever-evolving tools and its various applications. So how would you summarize the importance of metrology maybe for someone learning about it for the first time?
Great question. Thank you. So metrology, of course, is the science of measurement. With the CMS, Coordinate Metrology Society, and the work that we've done at Dirk Dimensions and many other folks around the world, especially in the U.S., our efforts are primarily focused on dimensional quality. So measuring things, measuring parts dimensionally, and confirming their accuracies, their manufacturing tolerances, things like this are the specialization that we get involved in within the broader framework of the entire concept of metrology. So the CMS and groups like that, there's others that are forming, as a matter of fact, that have formed over the years, and there's even some in Europe and Asia, are specifically looking at technologies and that measure things dimensionally, things like airplanes and power generation equipment, architecture, roads, bridges, things like this. As it relates to learning and maybe looking into this technology, coming into schools and programs for that, the first place I would look, of course, would be the CMS website. There's a host of information about this. Schools are adding programs and have over the years added programs around dimensional metrology, using technology, using computer-based tools to measure the lengths and widths and tolerances of things. It sounds simple. It isn't. Making airplanes fly, making windmills spin, things like this. It's pretty difficult, actually, to do these things accurately, and that's what the world of dimensional metrology that we focus on is all about.
Well, Michael, you kind of touched on something there. A lot of people, when they think of 3D or coordinate metrology, they think of it in terms of manufacturing and assembly, and very often in terms of large-scale manufacturing and assembly, so very industrial applications. But it also has some more subtle uses that really touch people's lives. Can you explain about that a little bit?
Sure. And you may be even seeing some of these, hopefully, behind me. We're showcasing some imagery of things that we've worked on, projects that we've worked on over the years with our 3D coordinate metrology tools. And you're seeing some that include art and sculpture. You're seeing architecture and buildings and historic preservation applications that we work with. So, fundamentally, the concept of measuring things includes the idea of documenting whether it's large structures, airplanes, for example, or buildings in the case of historic preservation, or sites. Also small things in the case of small manufactured items for a car or an airplane, but it could also be a cultural artifact, something that's in a museum or something that somebody finds very precious to them. These same tools, these laser scanners and optical metrology tools, are often applied to fields beyond manufacturing, as you're pointing out, for these types of documenting projects, or even reproductions. To put one a case study that's a little bit more poignant in terms of changing people's lives, we work regularly, and you may see a slide or two show up, with the idea of scanning people, for the idea of making cosmetically accurate, for example, facial prosthetics. So we use the same coordinate metrology tools that we might use for measuring an airplane part, but we might be measuring someone's ear because they may have lost their other ear. We can scan their existing ear. We can mirror it in the computer, physically bring it out of the computer using technologies like 3D printing, and we can literally make someone a new ear that's exactly equal to the opposite ear. And this does change people's lives. There's no doubt about it. We work with institutions like Johns Hopkins Hospital here in Baltimore, where we're located. We work with Walter Reed and soldiers that have come back from war zones and have been afflicted by these types of conditions. And I can tell you it's a very rewarding aspect of the work that we do.
Yeah, it's amazing. I mean, and as you move forward, I mean, do you see that? Obviously, that's going to continue to improve and improve people's lives as you go forward. I mean, what is the kind of the bleeding edge of that moving forward? I mean, how far do you think we can take these prosthetics and this ability to scan and accurately, basically bring in parts of people's bodies into their body and make them function? I mean, how far can we take this, do you think?
It really is growing, Mike. It really is. I mean, the prosthetics and the medical community are really just starting to explore this. We've been doing it a very long time, over 15, close to 20 years, with certain institutions, but it is starting to catch fire. The idea of 3D printing is definitely catching on, as we've seen. There's been many projects that have been focused in the news using simple desktop printers to make replacement hands that function, for example, for children. Because they grow so fast, the idea of making an expensive, say, $50,000 conventional prosthetic can be almost out of the question. So using literally a $50 worth of material, these organizations around the country, and we've printed hundreds of these for kids. You can literally change someone's life with something like that. Now, you can extend this to far more other, manufacturing and industrial applications. There's no question these types of technologies are moving in that. We're working with surgeons, we're working with doctors to take CT data from craniofacial patients and making aerospace level tooling to be used in surgery to help doctors cut as a cutting guide, help them in their surgical process, plan the surgeries digitally and virtually, visualize the surgeries, produce the surgeries in some cases using these surgical guides, and in many cases now we're moving into the idea of implantables that are used this technology through 3D printing. It really is changing lives. But there are other applications. Let me go this way. We use the same technology that we really perfected to do these types of medical applications. Today we're using them for Hollywood, for scanning actors and props and sets and locations, because so many of our big budgets, movies have tremendous special effects. So the idea of scanning and digitizing, or essentially coordinate metrology of actors and these types of things, and putting them into the computer very accurately. So then when we watch these movies, they look precisely like the items that we've scanned. This is interesting. Obviously, from a historic preservation perspective, we like to maintain a level of precision and accuracy for these types of sites too. We scanned Mount Vernon in Washington, D.C., outside of Washington, George Washington's house, for example, every aspect of it, and many other things like that, including the Liberty Bell, the Tomb of the Unknown Soldier, the Iwo Jima Memorial, and many other things. And some of those slides you may even see behind me at times.
Well, as I mentioned in your intro, and you've devoted a lot of time and a lot of energy to the Coordinate Metrology Society, including multiple terms on its executive committee. So how do you see the evolution of the society and some of its exciting new developments, things like the certification program that is rolling out now, or the Precision Path Consortium?
Right, these are fabulous programs, and my hope is that the committee is able to spend more time working on these types of things. The CMS has been around over 30 years. It's a fabulous, longstanding group of individuals that volunteer their time year after year to put on essentially a conference, usually in the summertime. This year it will be coming up in July in Nashville, Tennessee. Brings together individuals, vendors, exhibitors, professionals, academics as well, from all over the world, to come together every year for a week to talk about the idea of coordinate metrology, the idea of using these tools for really important applications within aerospace and automotive and power generation and many other critical applications. So the committee, the CMS committee, that is, essentially volunteers year after year. They put their time and effort into putting this conference together. It's a really a tremendous effort. As you mentioned, I was part of that for over 4 years. My efforts were regarding the conference as it relates to the technical presentations, which is really something that can't be missed. There's unparalleled technical content presented at the CMSC each year in terms of how to use these types of tools. What are the applications, accuracy tests, all kinds of issues and things that people can present, to come together to speak about these topics, that share the knowledge across the planet as widely as possible to grow the fields. You mentioned the Precision Path. This is a fabulous group of brand new, relatively new within the last year, bringing essentially a consortium of people pulling together their time and effort under a grant that they received to push out the concept of large-scale metrology in a broader way. This is fabulous. There are a number, I don't know if most people are aware of this, but there are a number of initiatives around the idea of innovation institutes that have been formed. One in particular, two in particular to probably connect with us directly. One is more on 3D printing side of things called America Makes, which is all of these are President Obama's innovation institutes that fall under NIST management. Another one is called DMDII, which is out of Chicago. It's about a year, maybe 2 years old. Also a very strong innovation institute around the idea of advanced manufacturing. Clearly with computers coming on in the last 25 years, and hitting the metrology space as we know it, as it has so deeply, these tools are becoming computerized in such a way that it's there's so much more they can do to affect the quality of manufacturing. So having a organization such as DMDII, as well as America Makes, and now Precision Path, which is just starting a fledgling effort. This is the type of system that produces new things that share widely across the planet. The ideas, in our case, of dimensional metrology, and so we're very excited about that.
Well, thanks, Michael. Thanks, Michael, for kind of giving us an update on Precision Path and some of the other programs that are related that are really helping to strengthen American manufacturing and how all that ties into metrology.
And World Metrology Day.
And World Metrology Day. So thanks, Michael, for joining us this morning. It's Michael Raphael, President and CEO of Direct Dimensions. I have that right, Direct Dimensions, right?
Correct.
Okay, Thank you. I'll make sure I got the company name right there. Didn't want to mess that up. Michael, thanks for joining us, and we'll be seeing you in CMSC in just a couple months.
Very good. Thank you very much, folks.
Okay,
Enjoy World Metrology Day.
That's right.
Yeah.
Thanks, Michael.
Measure on.
We'll see you then. That's right. Yeah, good show. We'll be down there in a couple of months, like you say.